Okay, welcome to an example in which we are looking at a particle moves along the curve, that curve, y was negative 6x squared minus 5x plus 1, in such a way that dx dt is negative 8 units per minute. When the particle reaches the point 8, negative 423, it is moving, we've got to say, towards or away from the origin at a rate of what? Well, I just drew what might look like the curve. All I know is this is a U shape upside down, right? Because x squared graphs are always U shaped. Got a negative on the x squared term. It's a upside down U shape. So there's the graph. And I know there's some particle and it's moving along the curve. Now you might say, how do you know it's going to the left, Ms. Hearn? Well, because it tells me dx dt is negative 8, meaning it's right here. It's at the point over 8 down, right? Over 8 down 423. It told me that right at that moment, when the particle reaches, it's been going along from here. When it reaches that point, it's dx dt, its change in x is negative 8. So it's moving in the negative x direction, which means to the left. So right then, right at that instant, how fast is the particle moving towards the origin? Now, this is the origin right here, 0, 0. So step one is always identify the rate letters. So what are the rate letters? Well, they're giving me obviously dx dt, so x, and they're asking me, what are they asking me for? It's saying it's moving towards or away from the origin at a rate. Well, what's that? Well, that's the distance it is from the origin. So that's distance. And how do you do that? That is the square root of x squared plus y squared. Why is that? Well, because over x down y, this is the x coordinate, this is the y coordinate, this is d, right? And so x squared plus y squared is d squared. And so then root both sides, d is the square root of x squared plus y squared. See how I did that? The distance the point is from the origin, it's like a little right triangle. How do you know? Because that's how xy coordinates work, right? Over x, up or down y. This is the x, this is the y. So right points on an axis system are xy points. They make a little right triangle. And so you can do the a squared plus b squared is c squared. In this case, x squared plus y squared is d squared. Root both sides. So the distance is the square root of x squared plus y squared. So they, in fact, why don't distance, or let me just call it distance. How about I go, yeah, I'll just call it distance. So that's the other one that they want me to find, distance. So those are the two rates, and I'll go d distance dt. And that's what they're asking for. How far, right? Um, at the rate it's moving towards or away from the origin. We know it's moving towards the origin, right? Because it's moving in the negative x direction from over 8, positive 8. From positive 8, it's moving in the negative x direction along the curve. It doesn't go straight, it goes along the curve. But as it does, it's getting closer to the origin. All right. So identified our rate variables. Our rate variables, I'm going to use dis as my as a variable. Is that well, maybe that'd be confusing. Maybe I better call it C. Yeah, maybe I better call it C because it's like A, B, and C. How about that? I'll call it C. So C, which is the distance, is there. Just call that C. So that's the other letter. So our two rate variables, they give me dx dt. They're asking me for dc dt, where C is the distance of the hypotenuse of that triangle. The length, the point is from the origin. All right, back to business. So step two. Step two, d dt both sides. Oh, wait, no, I'm sorry. We need an equation. We need an equation with X and C as the only letters. So how do we get an equation with X and C as the only letters? Well, we have an equation with X and C as the only letters. Right here, we have x squared plus y squared. I'll just call it c squared. I should just call this c squared. X squared plus y squared is c squared, right? We didn't get c. So there it is. But wait a minute, that it's got x, it's got c, but it's also got y. We can't have y. Only letters X and C. That's really important. That's why on step one, I identify the rate letters because I got to know the ones I need. I need to have them and nothing else, right? They give me dx dt and they ask me for dc dt, the distance, the right triangle from the point to the origin, right? So what am I going to do? Well, that's where I take this y and I plug in right there. You see what's happened? It's getting a little complex, I know. But we're going to go, oh, so I'll bring this, let me bring this down. So x squared, right here, x squared plus y squared is c squared. When I come to y squared, what is y? It's that. Minus 6x squared minus that. So minus 6x squared minus 5x plus 1 squared is c squared. Did I get that right? Minus 5x plus 1, yeah. So minus 5x plus 1, right? Minus 5x plus 1, yeah. So you see what I just did there? I'm on step two right now. Step two, and I got an equation with X and C as my only letter. Step one was to identify those letters, X and C. Now I've got an equation. See how this equation has only X and C and then numbers? So that's good. All right, on to step three, ddt both sides. ddt both sides, you know that. So I'm going to take the derivative with respect to time of the left side and the derivative with respect to time of the right side. Okay, once again, now this is implicitly, so what's going to happen? The 2 is going to drop down. We're going to get 2x dx dt. Don't forget that, right? Plus, oh, this is going to get kind of ugly, isn't it? Yeah, it really is. It really is. What can we do? Well, yeah, I guess we'll do it. Bring down the 2, and we got keep the inside the same, minus 6x squared minus 5x plus 1. Lower it to 1, right? Subtract 1 from it. And then go chain rule. Chain rule says times the derivative of the inside function, which is what? Bring this down. Minus 12x dx dt minus 5 dx dt. That's all multiplied there. And then that's equal to, bring the 2 down, 2c dc dt. Whew, what a mess. Okay, so we got to be really careful on that. So now we got to plug in our stuff. What are we looking for on this one? We're looking for dc dt. So really, um, really we've got a mess, don't we? But dc dt can be found right now. Let's just plug in some stuff. So I'm going to say, okay, and over here it's 2. The step 4 is plug in. I should just say step 4. Plug in all the numbers. So 2, what is x? Do we know x? Oh yeah, this is x, this is y. X is 8. So x is 8. That's nice. So we'll put in 8 here. And what's dx dt? Oh, dx dt is negative 8. So that's nice, right? Keep going. Plus 2. Now here we've got minus 6. Again, x is 8. Minus 5 times 8 plus 1. And now times minus 12 times 8. Dx dt is negative 8 again, right? Minus 5 times dx dt again is negative 8 equals 2c dc dt. All right, and what I'm going to do now is I'm going to divide both sides by 2c, 2c. Boom, boom, because I want dc dt. And do I know c? Um, don't think I do yet. So I'm going to pick out some numbers here. You can use, I would type into Desmos. This would be 64 times 2 So I'm going to try to do some by hand calculation. I was on red there. There we go. Okay, some by hand calculation. So that's going to be 2 times 64. That's going to be 128 negative plus 2 times, oh, this is just it's getting too ugly. You're going to have to type it on Desmos. What is C though? How do I get C? That's what I'm wondering about. Well, I know how to get C actually. I just don't feel like doing it. C, 2C on the bottom here. Oops. Remember, x squared plus y squared is c squared. We know x and y right here, x and y. 8 and minus 423, 8 and minus 423 squared is c squared. So then we got to hit the buttons on our calculator and then, root both sides and we get c. So on the bottom, that's going to be 2 times the square root of 8 squared plus minus 423 squared, because that's C. All right, you tracking with me? I know it's a tough one. There's C. And then on the top, we just got to compute all that stuff. It's kind of awful. So, yeah, wow. And then that'll be dc dt. All right, let's do it. In fact, I'm going to stop doing it. Come on. I'm going to stop doing it by hand. I'm going to write the word Desmos, and I'm going to go to Desmos with you. Let's do it. I got to see it happen. 2 times 8 times negative 8. Let's go. 2 times 8 times negative 8. 2 times 8 times negative 8. 2 times 8 times negative 8. I do a fraction. 2 times 8 times negative 8. What's next? 2, 8, negative 8. 2 parentheses, negative 6, 8 squared. 2 parentheses. It's 2. Where's the parentheses? Parentheses, I'm losing it here. Is that right? Plus 2 parentheses. Yeah, plus 2. Negative 6 times 8 squared. 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 Minus 5 times 8 plus 1. Minus 5 times 8 plus 1. Minus 5 times 8 plus 1, close parentheses. Okay. And then the next part, oh, times minus 12, 8 minus 8, minus 12, 8 minus 8. So times parentheses minus 12. Come on. Minus 12 times 8 times minus 8. Minus 12, 8 minus 8. Minus 5 times minus 8. Minus 5 times minus 8. So minus 5 times minus 8, close parentheses. That's a lot of craziness. Over 2 times c, over 2 times the square root of 8 squared plus over 2 times the square root of 8 squared plus, we're so close. Minus 423. I'm just going to go 423 squared. It's squared anyway, whatever. Squared equals minus 808,006 minus 808,006 minus 808. Oh, that's beautiful. 007, I guess it rounds. We got it's minus, which means the distance C is shrinking. The distance of C is getting smaller. Remember, when a rate is increasing, getting bigger, if C was getting bigger, that'd be a positive. If C is shrinking, if it's getting smaller, meaning as the point moves closer here, it's getting closer to the origin. The distance to the origin is getting closer and closer and closer. So anyway, they want you still to put in a positive answer here. 808.007. Is that what we got? 808.00. Yeah, 6/8 round to 7. So we got it. And there it is, just as easy as that. There we go.